All right, Grant. What is it you don't understand? Talk to me. Or what do you understand so far?
Sir, sir, at 905 I just got in, sir, and you're talking about how to solve
Alright,
in
Mark, actually.
All right, persons who are not talking, just mute the mics and allow Grant to talk. Go ahead, sir.
sir, I was saying, sir, I got in, sir, you were doing density and why ships float, sir, and then saying working out, I don't understand.
We didn't really do a work, What we did was just a comparison, right? Because what Ariane said was that with inside of a boat, right, it is filled with air, while it is made up of metal, right? On the inside, we have a lot of air inside. You understand? Which is going to help us in regarding to that boat staying afloat. And how we looked at it was from the fact that we're comparing the density of gas, right, and the density of water to draw our conclusion. You understand? Seeing that we have the air inside here, if we have a lot of air in here, and the density is much less than that of the liquid, then clearly the boat is going to float, despite the fact that it is made up of metal. You understand? So that's what we were drawing reference to, right? And if you look on my screen here, we were talking about the fact that weight does exist in the sense that weight is going to act down on the water surface. Now, there's the upthrust force that's going to act in the opposite direction, right? And we're saying that those are two things that we consider whenever we're talking about floating or sinking. Because obviously, if the weight of this boat was much greater than the upthrust force of the water, then it's going to sink, right? Because obviously it's going to push all the way down. But now, if I'm able to strike a balance in the sense that if I matches my boat weight with the weight of the water or the upthrust force, then it's going to balance. It's going to be a balanced force, right? So that's what we're saying in a nutshell. All right, moving along, guys, to another aspect of this course. I hope persons understand. When we talk about motion, Gabriel, talk to me.
To mute your mic.
Gabriel, aren't you in class today? Did I mark you absent? All right, Emmanuel, what do you think you know about motion? Tell me. Emmanuel, I'm talking to you, sir.
Yes, sir.
Motion. When you hear that term motion, what comes to mind?
So like movement.
Okay, so you said movement, all right. Grant, talk to me. When you think about motion, what comes to mind?
Sir, why you change the screen?
What do you mean why I change the screen? Because we're moving on to something new, Chelsea. What's the problem?
Okay, sir.
What's wrong? Tell me.
I never finished writing one part. Exhausted.
Just summarize it, all right? Grant, I'm talking to you, sir.
Yes, sir.
Motion. What comes to mind when you talk about motion?
So the movement of an object or thing.
All right. So I'm hearing the word movement. I don't want to hear much of that anymore. Can somebody add something else?
There is a changing of place or position of an object.
All right. Okay. Fair enough. Based on what is on my screen, I want to start talk about distance and displacement. Can anyone refresh my memory in regards to what kind of quantity would be distance, in the sense that would it be a scalar quantity or a vector quantity?
Vector. Vector, sir.
Which one are you referring to as vector?
The distance.
Are you sure?
Distance is scalar.
Yes.
I'm not sure, just asking. Not sure.
No, you see, you weren't asking Chelsea, you were giving an answer. You understand?
Yes, sir, but I'm not sure of my answer.
Okay. So, Chelsea, were you in the class when we were doing the whole scalar and vector quantity? Do you have that notes in your book?
Mm. No, sir.
So you missed that class. Gosh. All right. For persons who were at that class, right? Distance and displacement, right? We made mention. As a matter of fact, I can pull up that thing too. So when we're talking about vector quantities, we highlighted that velocity is a vector quantity, displacement is a vector quantity, force is a vector quantity, right? And what can we say a vector quantity is again? Let me see. Come on, guys. Vector quantity, just refresh my memory quickly.
A vector quantity is associated with measurements taken with objects that are in motion.
All right. But now, in a nutshell, you understand? I don't want the definition out of the book. I want you to be able to pinpoint what a vector quantity is. Once you come across it, you must know. Not to go back to say, it has to do with motion or what. So yes, we know that, right? And that just came from the book. I want you to be able to tell me that, it's a quantity that whenever you take the measurement, you're able to get the magnitude, or in other words, you can say size and the direction, right? Do we see that? Hello?
Yes, sir.
Right? I'm not saying you're incorrect, right? But I just want you not to be giving me straight from the book, right? So yes, vector quantities, all of them have to do with motion. We agree with that, right? But the key two things that must be mentioned is that whenever you take that measurement, there must be a magnitude, which means there must be a value, a numerical value, and there must also be a stated direction. Your direction can either be used using an arrow, or you can say north, south, east, west, up, down, forward, backward. You understand? Negative and positive signs, we use those to highlight direction. And that's just a recap.
Okay, sir.
Now, we also made mention to scalar quantities, and we said that distance is a scalar quantity. Right? Now, back to my screen here. Let me just scroll up quickly. All right, can somebody read that for me?
As we learned earlier, distance is a scalar quantity. Distance is a measure of the total path traveled by an object. Displacement is a vector quantity, which is a measure of the shortest distance between the start point and the destination. Therefore, displacement tells us how far the object has moved from its start point and the direction in which it has moved.
Wonderful. You're such a brilliant reader. I like it when you read. All right. Now, typically, yeah, because you don't like to read, not true?
Nope.
I hear you, man. All right. So imagine, right? You in your house right now, and you need to go down to the shop to buy a loaf of bread. You understand? So this is your house. I don't know who lives in the small house, but
Terminariski.
Gabriel, where's Gabriel? Gabriel, remember your house, Gabriel? I wonder if she's here. Oh yeah. So Gabriel, is here, and she's hungry. Well, as a matter of fact, Chelsea is hungry, because Chelsea's always hungry, right? So here's Chelsea now, wants to go buy a loaf of bread, and clearly she has two options, in the sense that she can go through, she can travel on the road, which is this thing here, the main road, going windy road or whatsoever it is, or she remembered a shortcut that could, lend her to reach in there much faster, right, Chelsea? So which of these paths What do you think as a hungry person right now?
The displacement cause it's shorter and I can get my food quicker.
I know you would have done that. Yes. So pretty much, guys, right? As the reader just said a while ago, right? That your distance is a measure of the total path traveled by an object. So whatsoever, path that object took. So if you had a cow going through the farm, grazing, whatsoever, right? This would be the path that it took. That's the distance, right? Now, clearly from this, we cannot get a distinct direction. You understand? So we it's hard for us to decipher what is the direction of, this cow that is moving within this path, right? Now, if we look at displacement on the other hand, we see where it is now the shortest, right, distance between the starting point and the end point. Cool? So it's basically you taking a ruler or a straight edge and join that line from your starting point to the end point, right? Mind you that we're talking about vector quantities. So we have to use an arrow, right? And then now this part here is what we call the tail. Don't put a circle around it, buddy. I'm just highlighting that part. That part is known as the tail of your vector, whereas this part is the head. Cool? The head of the arrow shows the direction, right? So you want the head of the arrow to point in the direction in which, that vector, that displacement vector is. You understand? You understand so far, guys?
Yes, sir.
Yes, sir.
One second, man. Getting my, I don't appreciate it, guys. Today is Teachers Day, and not one of you say Happy Teachers Day, sir. Respect your what is that?
Happy Teachers Day, sir. Sir, but that's too much
Sir,
work.
you said the same
Wow,
thing in the
No, no matter about WhatsApp group. You understand?
Sir,
One
but you know
man, one
that's
special.
special.
I would say that a Chelsea, Chelsea, know yourself.
Say that.
Remember when you said, "Oh, me ugly Michaela, I wasn't on that car."
Do you tell us you're ugly, Chelsea?
You-
That? Chelsea, you said that somebody was ugly. I said, Chelsea, you're supposed to talk. That's all I said.
Sir, whatever you know. It wasn't on that car. You never understand.
Yeah, but don't worry about that. Still. I mean, let's proceed again, right? So let's look at something else, guys. In terms of this guy here, he's doing some skiing, right? I don't know if any of you guys ever done that, but I can just imagine how fun that is going to be. I would have been. All right, so here's this guy. He's at the position A, and now the question really is to determine the displacement and the distance at each point. What would be my starting point here? What would be the starting point, guys?
Sir, which one are you talking about now?
Yeah, man, the bottom one here, this one. So I'm saying now, looking at this whole setup, right? Which point? Because you have to choose a starting point. You understand? Based on what you're seeing there, what do you think, or where would you start, so to speak?
Sir, A.
A, and why you say that?
Because equal to 0 minute.
You're on the right path. Continue.
Sir, we don't know nothing else.
What equal to 0, madam?
T
0 what? 0 what? Tell me. What's the unit there?
minute.
Good. So if it is 0 minutes, it means you say, all right. Just like when Usain Bolt is on the track, right? Once he's in the starting block, he hasn't run any seconds as yet. So that's 0 seconds, right? But the very moment he moves off, then now we're gonna start lapsing, how much time did it take for him to run that 100 meter. So good, you're on the right path, madam. So don't feel like you're not there. So because this guy is at 0 minutes, he hasn't started moving, so we're gonna call it our starting point. All right. Now, clearly, if we're talking about our A, B, C, D, whatsoever it is, which letter would come next?
B.
B. Now, the aim here is for us to determine the distance traveled, right, and the displacement between each point, right? So go ahead now, look at all the measurements that are there. Then now you're going to work out your distance, right? And then after that, now I want you to think about or work out the displacement. Remember we said that your distance is the total path traveled, whereas your displacement is the shortest point from starting point to end point. Cool? So look at that situation. Starting at A, going to B, what would be what and what? Let me know. It's only the mathematics, so you can maybe use your calculator, I don't know. But nothing hard. Give you guys 2 minutes. Are we there? Are we getting through, by the way? Are we attempting the question?
Okay.
Huh? Anastasia, we still go. Oh. Randall, are you doing the question?
Sir, what should we do? Find the displacement?
God Almighty, Jesse, look at
Yes,
me.
sir, because I'm confused.
Then
Or-
why not do something? I've been saying this over and over, guys, and you haven't said anything to me. So I said, determine the displacement and the distance at each point. We highlighted the starting point, right? And we're saying that based on this now, we're going to say, all right, what's the next point that he's going to move to? He's going to move to B. So we're saying, let's calculate the distance that he would have traveled from A to B. And we also need to find the displacement between that point.
So, sir, that would be 180 would be the distance, sir, 180 meters.
I'm listening to you, Chelsea. Speak with confidence when you're talking to me, please.
So it would be 180 meters, sir. And the displacement would be, so that's Sir, that would be 100. The displacement would be 100 meters.
Why you say it's 100?
Or 80. I'm not sure which one.
All right. So refresh your memory in regards to what's a displacement in terms of the definition.
Sir, displacement is the shortest path that one would take.
From where to where?
Sir?
From where to where? From where to where?
From
From the start point to the destination.
All right. So what would be the start point here for that situation? We're talking about the displacement here. And what would be the end point?
The start point says that line. The line at the end.
Start point is A, and the end point there is B, right? Yeah, right here would be the start point. We can agree that. But
Yes,
no.
sir, that's what I'm saying.
So now we say it's the shortest path from the start point to the end path. End path is here. What is that distance, or what is that displacement that we're getting with? If we're supposed to measure it, you understand? What would we get? So Chelsea, by the way, the first thing that you said was correct, right? 180 meters for the distance is correct, right? So that's the total path that he had traveled, right? Now, clearly, guys, in this case, the displacement would be the same value as the distance. So it's still going to be 180 meters, right? But seeing that we're talking about a vector quantity, we have to incorporate a direction. So we're going to say 180 meters right. You understand? So right would represent the direction. Now remember, guys, this is the shortest point between the starting point and the end point, right? It will be the same distance that was covered. Good. Now let us consider now the distance. Let's erase this quickly. Let us consider the distance between A and C, and let's consider displacement as well. So we need to find the distance, and we also need to find the displacement using the knowledge that we know. You understand? Can we?
Sir, is it 60 meters?
What value are you giving me for? What are you telling me?
From A to C.
What's the distance?
60 meters.
You said how much?
60 meters.
Well, you said 60 meters. Why you say that?
Sir, I just subtracted 40 from 100. I just said it.
Now remember, go back to your definition in regards to distance, right? Remember, I am traveling from one location. So I traveled here, which is A. I went to B, but now I am back at what do you call this now? At another point which is known as C.
Oh, sir, I thought you were just saying A to C. I didn't know you were going from B to C now.
Sir,
Yeah. Yes. Go ahead. Talk to me. I feel like some person don't understand, right? And clearly they're not saying so. Jabari,
Yes, sir.
you don't understand, right?
I'm fine.
Why you're not answering when I ask a question? That's the whole thing. If you huh? So determine the answer then. Tell me what's the answer here.
Sir, I don't know.
Sorry, breaking up. I'm not hearing properly.
So you have no problem, you don't highlight it, my friend. How does that make sense? Huh?
Very confusing.
Sir,
So that a while ago.
Said what, sir?
sir, 220.
A chin said that. A chin said that.
Confusing.
Alright, Chin, I hear you.
Sir, I think I got the answer now.
Tell me your answer quickly.
Sir, so if you're saying B to C again, right, sir?
Uh-huh.
Wouldn't it be 140 meters?
Now let's look at it. So here I have 40 meters here, right? I need to add this 40 meters to my 100 meter here. Clearly? So that's 140 so far. Now, from here to here is 40. So overall this is 180 so far. So from A to B is 180. Now this guy had to travel another 100 meters to get to C. Cool? So I have to now put everything together. So when he traveled from A to B, that was 100 meters. Now when he traveled from B to C, that's 100. So when you do the math, that's 280 meters in terms of the total path that he traveled, right? This is the amount of distance that he covered. Because all you're simply doing is measuring all of that movement that he made from the start point to B, then to C.
Excuse me, sir.
Yes.
So, how is B to C 100 meters now?
From B to oh wait, let me check something quickly. Yeah, you're right. Let me just check something quickly. So it would be 140 rather, right? So thank you for that. So from B to C, it's going to be 140, right? So when you do all of that maths now, it's going to be 280. Is that correct now? No, it won't be 280. It's going to be I think it's 320 because 180 plus 140, right? Help me out to the maths, guys. Come on. 180.
Sir, you're right.
Yes, exactly. Right? So this is the total distance that the guy traveled. Now, as in regards to the displacement is that shortest distance, so to speak, right, from the starting point to the end point. So he ended at C. So you now need to look at, where's going to be my starting, where's going to be my ending. What's the distance between those 2 points? And from this, what do you think that's going to be?
Sir, what is the shortest point, sir? Wouldn't it be the 140?
We're talking about remember the displacement is the shortest point from the starting point to the end point. The starting point is A, end point is C. What is the distance between that?
40 meters, that's the
40 meters, exactly. Because this is what it is, from here to here, right? So that's 40 meters, right? But no, we now need to incorporate the direction. He's moving to the left, so he does right and left, right? He's going in that direction. All right. Now, there's another situation that I wanted to highlight before we go. Let me just draw it up here. So imagine Imagine I have a box, right? This is a 5. Let's use a smaller marker. It's my starting point. All right, now we'll call this 5 meters. 5 meters. We're going to call this 3 meters. Clearly, this is the rectangle. So whatever is on the top side here, it's going to be reflected down here. Now, let's imagine that this is your home, right? And you travel from home to school. This is the path that you take. You go in this direction. So this is school, right? And then now, when you leave school, you just follow this path right here, and you go straight home, right? The question now would be, what would be the displacement, right? If you were, you know, how far away would you be? Well, yeah, it's kind of a bit tricky. Let me see how much I can ask you. I want to ask you the question that, yeah, what would be the displacement, right? You know, from your home to, so clearly your home is the end point and your home is the starting point, right? What would be the displacement at that point? So this is your home. Your home is the starting point, right? Now, to travel from home to school and go back to home, we can find the distance easily. It's by just adding up the sides. So 5 meters here plus 3, that's 8 so far, 8 meters, plus another 5, that is what? 13. 13 plus 3.
Overall.
16 meters. That's the entire distance that you travel, right? Now my question is, what would be your displacement from your starting point to your end point?
8.
Can't be 8. So your starting point is your end point. Remember, displacement is the shortest point from the start point to the end point. So if you start at your starting point and you go back on your end point, what's your displacement? Just guess something, guys. Guess something. If you know, just guess something.
5.
You tell the Galaxy Tab 8 2016. What's your name again?
Sir, 5.
You guessing 5. Alright. Rihanna, what do you think? Talk to me, Rihanna. I want to hear from you.
Sir,
Yeah, man, what do you think? What is the displacement from your starting point to your end point?
sir, 60 meters.
No, that's the distance. Distance is the total path traveled. You understand? You get that part?
Yes, sir.
What is the displacement? In terms of definition.
The shortest point.
The shortest distance.
Shortest distance from a starting point to the end point. So think about it. You understand? If you start at your bedroom and you end up back at your bedroom, what's the displacement from the starting point to the end point?
Bedroom.
Sir, is it 0 meters?
Clearly it's 0. Clearly it is 0. Because you ended up back where you started from. Right? So there's no distance between the starting and the end point. And I hope persons are understanding now. So if you start somewhere and you end up back at the same point, you don't have a distance to measure. You don't have no displacement there because you went back to where you were. Imagine you displaced you know, say, you bounced a ball, right? And when you realize the ball went back to the original position, there's no displacement. It has gone back to the original space. So hence now we can say that it's 0 because it went back to the original position. Gabriel. All right. Spence. You understanding, Spence?
Which Spencer?
Huh?
Which Spencer?
Which Spence you be?
A Spencer.
No, give me your full name, man.
Elena Spencer.
Yeah, man. You may talk to.
Okay, sir. No, sir. Can you just go and...
You see on the stay bad? Huh?
Sir, I wanted you to finish what you were doing before.
No, man. You not finish, man. Interrupt me, man. But we are almost at the end of the class session still, right? But you see, guys, I don't want you to be here. You understand? Not understanding. Because it's going to defeat the purpose of we having a class now. You know what I mean? Because if you don't understand, say that you don't understand from early so that I can go some Babs and clarify the point and try my best to make it out to you. But, you know, to just close up, all I was saying is that anyhow you move from here, so, right? To here, so. You go school and you travel from school, you go to the bus park, and then you go straight back home, right? We can look at it from a mathematical standpoint, but not today, right? But with that, you know, there's no distance at this point, meaning that, you know, wherever you start, if I'm supposed to measure the distance there and measure the distance where I stopped, if my starting point and my stopping point is the same place, right? It means that then, you know, the displacement from the starting to the stopping point has to be 0, right? Because you ended up back where you started. So hence we said there's no displacement. When you said you displace something, means that you push it out of its original position, right? Seeing that we went back to our final position where we started off with, right? Then we can say that, you know, there was no displacement. But we can agree that the total distance is going to be 16 meters because adding up all the part that you took is going to be 16. All right, guys, we have to end it here. But, you know, do some reading up for me, please. Right, I'll try my best to make this video possible for persons who came in late a little bit or whatsoever it is. Right, can't promise you how soon I'll get it out to you, but that's going to be it for today. Right, if you need any clarification, if you don't understand something, feel free to message me, and hopefully I get a chance to respond as soon as possible. But you know, don't feel left out if you don't understand. All right, link me on a one-way. All right, but take care of yourself, guys, and just stay good and quarantine and chill. All right.